Hi everyone, my name is Kevin George Buhain with student ID 10150526. And I will be discussing my assignment 2 for COMP3132. So first off is that I've run all the codes, as you can see. I'll just be explaining each line of codes. So we start by importing pandas and the train test split and the TensorFlow utility equal to categorical. And then we pass the path of the iris CSV to the file name variable. We read the iris dataset and then check the first 5 elements inside the iris dataset, which is here. As you can see here, the species are still in names like Setosa, versicolor, and virginica. So here we replace those names to numbers: 0 for Setosa, 1 for versicolor, and 2 for virginica. As you can see here, when we checked the first 5 elements again, the Setosa has been changed to 0. So we select the first 4 columns of the data frame, and then we select the last column as the label and call it Y. Here we split the data to X-train, X-test, Y-train, and Y-test. We have a 20% of test size, and our random state is 42. Here is the first 5 elements for X-train, first 5 elements for X-test, and the first 5 elements for Y-train and Y-test. Then we check the length of each X set. For X-train is 120 samples, and for X-test is 30 samples. So 30, that means it's the 20% of the 150 samples from iris dataset. And we convert Y-train and Y-test from categorical to one-hot encoded values. Here we import the sequential and the dense layers from TensorFlow Keras. So we created the model sequential, then added three layers. First layer have 100 neurons and with activation value. Then we input the shape as 4. For the second layer, it's 100 neurons again with activation value. And for the last layer, it's a 3 neurons with activation softmax. It's for probabilities. Lastly, to show the summary of the model, then we compile the model and we train the model. Here we have 10 batch size with 20 epochs and with the validation split of 0.2. This to see the value validation accuracy. There you go. So the loss is 0.17.39% with an accuracy of 89.98%. Sorry, almost 90%. Then we train another model, which is a small model, and then it's another sequential model. Instead of 100 neurons for the first layer, we have 10, then 10 for the second layer. we have the same output layer, which is 3 neurons and softmax. Then we compile and train the model. Here you can see that we have a 0.92.20 test loss, and then an accuracy of 0.73. So with a smaller model, we have less accuracy because we are training from less samples. Next is the small model 4 sequential. We add, we still use 10 neurons and for the first layer and the second layer, and 3 neurons for the third layer. But instead of having 20 epochs, we only have 10 batch size. No, sorry, we only have 4 epochs and then 10 batch size with the same validation split. So this batch right here is bad because we're only training for 4 epochs and we have a lower neurons to use for the training, which results in for the model to not learn to classify the iris compared to our first model, which has 100 neurons for the first and second layer. So how does changing number of hidden layers neurons affect performance? Adding more hidden layers or neurons usually increase the model's capacity. Higher capacity model can learn more complex patterns and sometimes give better training accuracy. Do we always suffer from overfitting if we add more hidden layers? No, we do not always suffer from overfitting just because we add more layers. Overfitting depends on several factors as the size and noise level of the dataset and the model capacity. How can we detect overfitting? We can detect it by comparing the model's performance, like training set and validation set, as we used for our small models earlier. Typical signs of overfitting is training accuracy keeps increasing while validation accuracy is low, or training loss continues to decrease while validation loss starts to increase, or if there is a large gap between the training accuracy and the validation accuracy. We can reduce overfitting by using regularization like L2 weight penalties, add a drop layer to randomly deactivate neurons during training, or use early stopping based on validation loss so we do not train for too many epochs. Lastly is the experiments. So we changed the optimizer to Adam here. As you can see here, test accuracy is 1. Here's for the second. Oops. Sorry, that's 1. 0.93.93. Here we changed the neurons for first and second layer to 50 instead of 100. So you can see here, accuracy is 96.67. Then we changed the number of epochs from 20 to 40. And lastly, we changed the batch size from 10 to 5. So from the 5 experiments, you can see that the highest accuracy would be changing the optimizer from what do you call this? RS rope to Adam. Sorry, one second. Yep. And for everything else, they're almost 96.67 for most of them, which doesn't change much. But other than that, um, I think the one with the biggest effect is changing the optimizer. So yeah, this is my assignment number 2 for COMP3132. Thank you for watching.